Alright, I'm sorry, last video got cut off. So in this video, we're gonna keep going and give you 3 examples. Alright, so if let's go back to the worksheet. Alright. Okay, let's look at example 1. Example 1, let me read the question for you very quick. A number cube with faces labeled 1 to 6 is rolled once. The number rolled with will be recorded as the outcome. So this is a standard dice. Every side is labeled 1 to 6 and there are 6 sides. Consider the following events. Event A is the number rolled is less than 5. So let's think about event A. The number rolled less than 5 can be what? Can be 1, 2, 3, 4, 5, right? So over here, I'm just listing all the outcome it can be. So let's look at event B. Event B, let's say the number is odd. If the number is odd, it can be 1, 3, 5, okay? And then they ask you to give the outcome for each following event. If there is more than one element in the set, separate with commas. So we're gonna look at A. Alright, A is talking about event A and B. So event A and B actually is talking about the number rolled is less than 5. Number rolled is less than 5. And at the same time, the number rolled has to be odd. So if you think about this event, it has to be less than 5, so it has to be 1, 2, 3, 4. Okay, over here, less than, they don't have 5. 1, 2, 3, 4. And in this 1, 2, 3, 4 has also be odd. So this one will be 1 and 3. Okay, that's it. So B is saying event A or B. So it's saying the number is less than 5 or the number is odd. So in the bracket, you should have a lot of stuff. And the first part of stuff is the number rolled is less than 5. All of this less than 5, so let's put it over here. And then they said the number is also odd. So all of this is odd. We can also put it here. However, in your bracket, you do not want to have duplicate because 1 is 1, like 3 is 3, like so you do not want to have duplicate. So you have 1 over here already, so let's erase this one. You have this 3 over here already, let's erase 3. Do you have 5? You don't have 5, so leave your answer like this. 1, 2, 3, 4, 5 is the number rolled is less than 5. In this question, they only ask you to give outcome, so you do not need to calculate probability, then you are done with here. Alright, so let's look at example 2. Example 2, this is called a Venn diagram. Venn diagram means like they use a box and 2 or more circles to represent the situation. So for example, let me read the question. The Venn diagram below shows 16 students in Mr. Henderson's class. The diagram shows the membership for science club. Science club is over here, okay? And the volleyball club. Volleyball club is over here. Note the Raphael is outside the circle since he's not a member of either club. So before we get started, the real question, let's look at the Venn diagram first. So science club is everybody in this circle, which is from Amy, Charmaine, and Linda, everything over here and everything in the middle. So everybody in this circle is in a science club. And the same thing, everybody in this circle are in the volleyball club. And what about in the middle? In the middle, they are in both of the circle, which means they are a member in the science club and volleyball club, okay? And then Raphael, they already explained the question. He is not part of either club, so he's outside of the circle. But he's still a student of one of the 16 students in Mr. Henderson's class. Alright, so let's look at the question. They said find the probability of the events below. Let me do this so we can have more space. Okay, alright, I'm not so sure what I'm doing. Okay, let me. Alright, okay, give me a second. I want to type something over here. Come on. Alright, let me put it over here. Alright, so let's see example over here. Let's put it over here. Okay, awesome. So probability of A is actually they want to find the probability of the students in the science club. So probability of students in the science club on the top, obviously we're gonna find all the science club on the top, and on the bottom we're gonna find everybody. On the bottom it's very easy to figure out because there are 16 students in his class, so on the bottom will be 16. On the top will be how many people is in the science club. So let's count. Amy, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 students in science club. So reduce the fraction divided by 2 on the top and bottom. You have 5 and over 8. That's the probability A. Probability of B, we are doing the same exactly thing. So probability of B is the volleyball club. So you're gonna do the volleyball club over all the people. So let's do that. So equals to the volleyball club. How many people in volleyball club? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 over all the people. Again, 16 students overall. And 16 over 6, there's nothing you need to reduce. Leave it here. Let's look at the next question. A or B. So they're asking you for, they're either in the volleyball class or club or the science club. So which means everybody inside either circles will be included. So how many students are those? If you count them, it will be 15 students. 15 students out of 60 students, 16 students overall. So it's 15 over 16. So that is A or B, science club or volleyball club. And the next one is A and B. So what's the difference of these two? If I say volleyball club or science club, which means that students can only join one club, then it can include it in our set. But and will be they have to involve in both clubs. So where we find that situation is in the middle. Those 4 kids are in the science club and the volleyball club. It's those 4 people. So over here I have, on the top we'll have my 4 kids over here, and on the bottom we'll have my total number, which is 16. That is the and situation. Alright, and the next one, they ask you to find probability of A plus probability of B minus probability of A and B. So this one, you just need to add everything you find together. I will use the fraction over 16, make them have the same denominator. It's easier to you to calculate. Okay, plus the B. Okay, minus A and B. And you can calculate that as 9 plus 10 is 19 minus 5 is 15 out of 16. Okay, so over here, do you see those two are exactly the same thing? So over here, I just want to let you know, even though we are not like give you the formula of not mutually exclusive event for our formula, but this is actually the formula for the addition rule if those two events are not mutually exclusive. So for example, this time, this one, science and volleyball can happen at the same time because those four people, so they are not mutually exclusive. If you want to calculate A or B, you can use this formula. Okay, all right, let's keep going. Select the probability that equals to that, A or B. We already confirmed that. So this is the Venn diagram question. Okay, and the next one, let's look at a two-way table. Two-way table is a very important concept, okay, very, very important. And I just want to let you know how to read the table. So the question is, on a particular day, a restaurant that opened for lunch and dinner had 177 customers. Each customer come in for one meal. An employee record that which meal each customer came in and whether the customer ordered a dessert. The data summarized in the table. This is the data. Suppose a customer from the day is choosing at random. Answer each part. Do not round intermediate computations and round your answers to the nearest hundreds. So over here, they have 177 customers. So I wish I can write on there, but I can't. So let's do some magic. All right. So over here, let me create this table very quick. I will just gonna create this table 3 by 3. Okay. You know what? Let's do a 4 by 4. Okay, so over here, I will just gonna copy on everything in the table for you. Okay, so let's first of all analyze all the information in the table. So this 37 here, what does that mean? This 37 means there are 37 people come in for lunch and ordered dessert. So this 37 means that there are 37 people come in for lunch, also ordered a dessert. And over here, this 73 is saying there are 73 people come in for lunch and did not order for dessert. If I get a total here, which is 110 people, what does this mean? This means this 110 people come in for lunch, period. We don't care is order dessert or not order dessert. Overall, all of them have 110 people come in for dinner. So come in for lunch. So for dinner, it's the same. For this 58 is saying 58 people come in have dinner and order dessert, and there are 9 people come in at dinner but did not order dessert. We can see like people like to have dessert in dinner, right? So they have 67 people come in for dinner, okay? And if we add those two together, it should be 177, which is the total customers they recorded. Let's run another total over here. So if we add this 37 and 58, which is 95, if I didn't calculate it wrong. So this 95 people is in the dinner time or lunch time, total people ordering dessert. And over here we have 82 of them. It's at the dinner time or not at the lunch time, the total number of people not order dessert. So the whole thing together is called a two-way table. They represent the information just like our Venn diagram do. So over here, if you go further in statistics, you will learn the Venn diagram and the two-way table. They represent the same situation. Just depends on what you consumer like to see, and you will use whichever table to present. So first question, what is the probability is the customer came for dinner? So on the top of your fraction will be your desirable outcome, which is the customer came for dinner. So which number is come for dinner? So this is dinner. This is the line of dinner. Dinner, dessert, dinner, now dessert. And this is the total number for coming for dinner. So on the top will be have 67, and on the bottom will be your total customer amount, which is 177. The two-way table is very important, especially when we next week we will get to conditional probability. It is so important. So you have to know what's going on here. And if you use your calculator, you can get 67 decimals. So you have 67, 177, 67 over 177. You get a decimal is 0.3785. So over here they said do now the answers nearest hundreds, so 2 digit. So 2 digit you will have 0.378, round 1 digit up 0.38. Okay, so over here it actually should have a approximately equal sign. Let's be more accurate. Okay, let's do this. Oh, oops. Oh, awesome. Here it is. And this is A. B, they ask you what is the probability that come for dinner or order a dessert? Came for dinner or order a dessert. Okay, so over here, came for dinner. Let me highlight, everybody come for dinner. Okay, this is my people come for dinner. Or order dessert, and those are the people order dessert. So we're gonna add all the colored ones together, which is whatever we have on the top. So 37 plus 58 plus 9 divided by 177. Okay, so you will have, let's copy and paste if we can to the decimal and see if we can get an answer. Oops, this is not right. Okay, let's do that. Okay, divided by 177. Alright, so it's 0.597, 7 go on a digit, 0.59. Approximately 0.59. Okay, so this is your formula. If we use the formula over here, we just discovered, so probability of A or B is also the probability of this. Let's see what will happen. So let's find the probability of A, which is come for dinner. So probability of come for dinner we have over here, 67 over 177, plus the probability of B, which is come order dessert. Order dessert is over here, which is 95 over 177. Over 177. Subtract by probability of A and B. Come for dinner and also order dessert. Come for dinner, also order dessert. Let's use blue, which is this number. So this number will be 58 over 177. So basically we're using 67 plus 95 minus 158. Let's put the whole thing in the decimal calculator. Probably not a good idea, just copy paste, but we'll see. Alright, okay, I need to change everything, so give me a second. Oops, come on. Alright, so do you see that we have exactly the same answer? So over here you can use both of the, if you can use either the formula or just directly read in the graph. So I will say so. Like in this stage, definitely just read directly from the two-way table is an easier way. But down in the road, we're gonna use this formula a lot, especially when they don't lay out the data for you. Okay. So all right. So this is our last example. Let me see if I can pull my face up. Nope, it's not a good idea.